So we have the following problem. Integral from 0 to 3 e to the negative x dx. Okay, so this one is asking, find an n value. So on this one, they don't give us the number of subintervals we have to make, but we're trying to find an n so that the error, the trapezoidal error, so Tn, is less than or equal to this number. So this is pretty tiny. So we're going to have to be pretty accurate, basically. Okay, so let's recall the formula. So error of the trapezoidal one is going to be less than or equal to k2. And again, this is the maximum that the second derivative can be. And then we have b minus a to the third over 12n squared. Okay, and then, yeah, so we don't know n. That's what we're trying to solve for. So let me just do that real quick. So we can get n by itself. So if we multiply the n squared up here and divide by error on both sides, we're going to get the following. To the third over 12 times the error. Okay, so then our final, okay, so n is ultimately going to equal the square root of k2 b minus a to the third over 12 times the error. Okay, so we know the error, right? They gave us this 10 to the negative 6, so that's good. We know b minus a is going to be 3, so b minus a equals 3, because 3 minus 0. And we just need to find k2. So k2 equals what? So our f of x, so our original function is e to the negative x. F prime of x equals negative, oh, that's an equal sign, negative e to the negative x. And f double prime is going to be a positive e to the negative x. Okay? And on our interval from 0 to 3, so let's say we have, well, we know that this graph, by now you should know that e to the negative x looks something like that. And we're going from 0 to 3. 0 to 3. So just by looking at this, you can tell that the maximum point is going to be when x equals 0. So f double prime of 0 equals e to the negative 0 equals 1. Alright, so this k2 is just going to be a 1, which is pretty convenient. So then when we plug everything in, we will get that, whoa, that was a funny square root, hold on. Okay, that looks more professional. 1, we're plugging in for the k2, and then b minus a is 3 raised to the third power, and we have 12 times 10 to the negative 6 on the bottom. And then this turns out to be roughly, or actually exactly, my calculator gave me exactly 1500. And if you're, because I know I was kind of surprised at how large the n value was, or it has to be less than or equal to. So anyways, oh, I guess that makes sense. So anyway, yeah, n should equal 1500 in order for our error to be less than this value. Okay, because like I said in the beginning, 10 to the negative 6, that's a pretty tiny number. So that means we can't have much inaccuracy. So that means we have to be really accurate, which means a larger n, right? So that's why we have such a big value of n. So n equals this. Okay?